All right. So today we'll talk about something called as generators in Python. Okay, something called as generators. So what do we mean by a generator? Okay, generators are special functions. Okay, generators are special functions that are similar to that of a functionality, similar to that of data collections or comprehensions. Okay, generators are special functions that are similar to that of data collections or comprehensions in Python, but are different in the way they are stored in memory. Okay, so now to be able to understand this part of the definition, we need to understand how data is stored in this format in the memory, right? Let us say we have created a list called as even list, which means is nothing but a list of numbers, even numbers, 2, 4, 6, 8, 10. Okay, so how this data is stored in RAM is, as we have discussed earlier, a variable heap and value heap, right? So these values are stored here as, not with the commas though, but yeah, something like this. Okay, now let us say we want to have another list that contains the double of these numbers, which is nothing but, let us say, double even list. Let us say we want to have a list of these numbers. I mean, the double of these numbers. So, what is the best way that we could do? There are two ways of doing it. One is by writing a for loop saying I is equal to 0. Sorry, by saying double even list is equal to empty list, which means we are initializing this list, and then saying for even number in even list. Okay, double even list dot append of e star 2, right? Which means after this for loop, we are going to get the result, the resulting values that will be stored in double even list will be 4, 8, 12, 16, 20. Isn't it so? Which means this is the source list, or this is the initial list, and this is the final list with the final values. Okay, so this is one way of creating a new list from an existing list. Okay, now let us look at the second way. Okay, the second way is using something called as comprehensions. Or simply list comprehensions in this scenario, where we will say double even list is equal to I for I in even list I star 2, which means after executing this comprehension, the double even list is going to store again 4, 8, 12, 16, 20. Okay. Now, in the case 1 and in the case 2, okay, in the case of 1 where we were using for loop, and in the case of 2 where we are using comprehension, okay, after the execution of these statements, the resulting list of values that we are talking about will be stored in the memory as 4, 6, 8, 12, 16, 4, 6, 12, 16, 20. All right. In the case of 1, in the case of 1 and in the case of 2, the resulting data structure is going to be stored completely in the memory. All the values are stored in the memory. Okay. Now, what if, okay, let us have a question. What if you don't have enough memory to store two lists of same size or any size? What if you don't have memory for enough memory to store this data? Okay. Again, pose another question. Even with lists, whenever we create a list, like in this scenario, after creating this list, I mean the double even list, we may not have to use the even list, right? All the time. Or maybe we may use even list multiple times down the line in your project, but we may not use double even list more than once in the project, right? All right. Let us understand. Let us say in the in the project that you are working with or in the program that you want to write, you want to create a data structure, okay? Want to have a data structure that you will use only once. Okay, you have a scenario where you want to use a data structure only once in your program. Okay, that is one use case. And let us say you don't have enough memory. Okay, or you want to write a memory efficient program. In the sense, you know that you don't need all the values from the resulting data structure. from the data structure. Okay. In these two scenarios, you don't creating a comprehension, a regular list or a dictionary or a set comprehension is not so memory efficient, or basically is not so efficient, right? And hence we have this concept of generators in Python. Okay. Now, what do generators precisely do? Okay. Generators do not realize all the values in memory. That is one thing they do, right? And writing generators in a special way, okay, writing generators in a special way will help us in getting those values only once. Which means after you fetch all the values from the generator, you may not be able to refetch the values. Helping with freeing up unnecessary space. Okay, this is how generators can help. All right, now let us first look at creating a generator where you can realize the values only once. Okay, realize the value only once. Okay, and even in this case, not all values are realized in the memory. What does we mean by all this realization? We'll talk about it in a bit. Okay, all right. Now let us go back to the same case, this thing that we have chosen earlier. Let us say we have an even list. 2, 4, 6, 8, 10. Okay. From this even list, I want a double even data structure, whatever it is. Okay. Such that I want the values only once. I get the values from the data structure only once. Okay. How to write I get this done, we have actually seen during our regular sessions. Okay. Which is nothing but we will create our variable name. Here the variable name is double even, and we will say instead of square brackets we will put parenthesis. Okay, and we will say the same thing for I in even list I star 2. Okay. Now this is called as generator expression. Okay. As soon as you execute this statement in our memory, this is variable heap. This is value heap, right? In our memory, we have the existing data structure 2, 4, 6, 8, 10. Instead of the realized values like in the earlier use case, we have something called as a generator expression. Okay, which means whenever I want values from this expression, I must do it like this. I must iteratively fetch the values for I in double even print I. And this loop and with this print statement is going to print the values 4, 8, 12, 16, 20. So, which means after the completion of this loop, let us say you try to write the same thing again. Okay, you try to write the same thing again and try to run this also, which means you are running this once and you are running this the second time, the same thing, the same code, but here nothing will be printed because all the values from this generator have been realized here, have been taken out here. This generator is now empty. Once we look at that, this particular thing in as an with an example, you should be able to understand that. Okay, so now what we will do is let us look at a demo. Is just the right. Okay, now what we will do is command S. Uh, all right. As we have discussed earlier, let us create even list. One second. Yeah. Let us create even list is equal to 2, 4, 6, 8, 10. Okay. Is the screen visible? Let me increase the size. Okay. Okay. This thing. All right. So even list is equal to those list of values. Okay. Now what we will do is let us create a double even generator. Okay. Here we will do x star 2 for x in even list. To avoid any confusion, let us use I itself. Okay. Now, when we print double event directly, Python space, ls minus l. Okay, I think we have to go one level up. Okay. Python space, generators in python.py. You see, when we printed double even, it told it is a generator expression. Generator expression. Okay. When we iterated over this list, it printed those values, right? As mentioned earlier, what we will do is let us repeat the same steps for the second time. And what we will do, printing the double even generator uh, for the first time. For the second time. Okay. Control L. What we will do is, no, let us open the terminal, and here we will do right. Let us write the code on the left side and then look at the result on the right side. Okay. You see, are you able to understand what we are trying to do here? We have created a list and we have created a generator. Okay. Now we are trying to prove that this object is nothing but a generator expression object. Okay. And then what are we doing here is we are trying to iterate over our generator and print the values for the first time. Okay. And again, we are trying to do the same thing. Our point earlier is when we run this, when it runs this for the first time, it prints the values. But when we try to run this for the second time, it will not print the values. That is our argument, right? Let us check if that is true. Let us say Python space generators in Python. You see, we have printed that it established that it is a generator object. And for the first time, when we iterated over, we got the values. But for the second time, when we tried to iterate over, no values are printed. Which means the values in this generator have been exhausted after iterating over the generator for the first time. Now you may say, like, what if I want to use the values for the second time also, or multiple times? Okay. If you want to use it just once more, then you can create your generator again like this. If you want to use it multiple times in your program, if you think you will need this generator or this data or this data structure multiple times in your program, then it is a better choice to go for a regular comprehension or a list comprehension instead of a generator comprehension. Okay. Until this part, we might have already learned, we might have already seen somewhere, something like that, right? Now, what we will do is let us create a generator function itself, not an expression, but generator function itself, if this point is understood. Okay. Yes, hoping that that has been covered. Now, what we will do is, let us create our own generators. Not generator expressions, but generators itself. Okay. So how can we do that? If you remember, we have opened our statement saying that generators are nothing but special kind of functions or special functions in Python. Okay. Which means they do look similar to that of functions. Okay. They do look similar to that of functions, but vary a little. Okay. Now, how do they look similar and how do they vary? We will discuss now. Let us take the same use case as earlier, where we have even list. Okay. Is equal to 2, 4, 6, 8, 10. Let us say we want a double even generator. So what we can do in this case is, okay, why this case is again is reason one. You don't want all values in the memory. Okay. Reason two, you want to iterate over them multiple times. Okay. Reason one for having this way of generators is you don't want all the values in the memory. The reason two for having the way we will be looking at is you want to iterate over those values. You want to fetch those values multiple times without creating them again and again and again. Okay. Okay. Right. Now we will look at, forget about this. We will talk about this in a bit. Okay. Now let us look at how can we define a generator. Define a generator in Python. Right. So my generator name will be same, double even gen we'll say. Okay. And as we have mentioned, the similarity of the syntaxes with functions come here. Okay. It is define def double even gen. Okay. And you pass in your list here. Okay. Now what this will do is, how we should define this is, for I in L or our list, Okay. Yield I star 2. Now observe the similarity with that of functions and observe the difference with that of functions. In functions, we use something called as return, right? To get out of the function. For a generator, if you want to create a generator, you must use yield. So how do those values or those keywords differ in their execution, in their properties? Okay. Let us say we have a function define ABC and you have return X. And you say you have defined A, B, C, D, and this says yield Y. Okay. When you call this ABC function, this whatever is happening inside the function will be forgotten or will be removed from memory. The calculations, whatever are happening, removed from memory, the values. And this value is returned to this line. Okay. But when you say yield, whatever calculations you are making here will not be removed from memory. Okay. But this value comes to your function call. Okay. But after which it can go back to this point again. This is theoretical. Okay. Let us understand the same thing in the context of this generator. Okay. Now, how can we use this generator is for I in double even gen. You need to use the parenthesis also and the semicolon and then say print I. So what it does is these lines we say like functions have function definition and function call, right? So when we create user defined generators in this format, also this is called as a generator function definition and this is generator function call. Okay, right. Now, how does the execution happen is it starts here. It looks at this generator function or for that matter, I need some space here. What shall we do? What shall we do? I'll get rid of that one. Okay. Let me redefine. Okay. For I in double even gen print I. Okay. Which means in your .py file, This is the one thing that your Python virtual machine wants to look at. Okay. As soon as it sees this, just like in the functions concept, it will store this in the memory. Right? Now let us say after having this in the memory, the Python virtual machine came across these two lines. Okay. Now what it does is it looks at this function, double event generator. Oh, okay. Which means there is a definition to this function in the memory. It comes to the memory and gets to the definition of the function. Okay. It looks at the function definition and then comes inside to the first line. Okay. To this function, we have to pass our even list. Right. Which means this even list argument is coming to the parameter. It is a positional parameter, which means our L is replaced by, just a second. Yeah, sorry. So what it does is it comes to, one second. Yes, it comes to this line now. And it got the even list in the argument. Okay. It came to this line now. Okay. Now the L is nothing but the values that the even list is referring to. Right. Now what it does is it iterates. It takes one value from L. Let us say 2, the first value from L. It comes to the next line. Right. It does 2 into 2, 4. And then yield. Yield means it has to come back here, right? It will come back here and print the value 4. Okay. After printing the value 4, from this line, the loop is still there, right? It goes back to this function, which means it goes to this line back again. And then it realizes that it is a yield keyword. And then there is a loop here. It goes back to the loop. Takes the next value 4, I, right? Takes the next value 4 into I. And then bring it here to the next line. Again, 4 into 2 becomes 8. And yield takes this value back to the print statement again. Now it prints 8. After printing, it will go back to the yield. And from yield, it will go to the loop again. Get the next value, 2, 4, 6. 6 into 2, 12. Take the value here again. Print 12. Come back. And this happens as long as there are values in this list, which is the last value is 10. After 10 is also, after 20 is printed, from the print statement again, it will go to yield. Okay, from the yield, it will go to the loop again, but realizes that there are no values in it and hence exit out. Any questions, anybody? Tarun and Sunil, any questions? All right. If no questions, then let us look at the coding part of it. Shall we? And before looking at the coding part of it, let us understand, or let us uh, let us understand two terms. Now, you guys are able to see this transfer of values or the context from your function call to the generator and back, right?
Yes.
Since we are able to play between our actual code and the generator expression, okay, these generator expressions are also called as coroutines. Okay, then what are functions called as? The other name for functions or functions can also be considered as something called as subroutines, which means your main program is the main routine, and your functions that you create in those main program are sub functions or subroutines. But when you create a generator expression, since you are moving back and forth between generators and these things, these together are called as coroutines. Any questions in the coroutine part? All right. Also, in this way, when you define a generator or when you define a generator using a generator expression in both ways, okay, in whichever way you do, you create an generator, the values are realized only when you loop over the generator, if you have observed that. As long as you are not looping over the generator, the values will not be realized. And therefore, generators are also called as lazy evaluated functions. Any questions in understanding these 2 points also? Okay. If no questions, clear all drawings. Let's get to the code. Let's clear this away and let us create our double event generator. Say some list. Okay. Now, again, the same thing. Same thing. You see, what I will do is, what I will change here is, we don't need to do this also. And what we will do is, so we need to pass in even list here. Right. You see, able to understand this is the generator that we have defined. But here we are calling the generator. Here we are calling it once and here we are calling it second time. And what we have discussed, whenever we are creating a generator like this, okay, yeah, whenever we are creating generator like this, whenever you use this generator, we should be able to get the values instead of when we create a generator with an expression. So when we create a generator with an expression, we can use the values only once. We can realize the values only once. But when we create a generator in this type of definition, then we can use it as many times as we want. Point one. And yet the values are realized only when the loop is running, whenever you call the generator. That is the idea that we wanted to show here. Right? It is saying there's some issue with I here. Redefining name I from outer scope. Chill, light, no problem. Okay, now let us run our code. Generators in python.py. You see a function, double event generator, a special type of function. You run it for the first time, you're getting all the values. You run it for the second time, you are getting all the values. But the values are directly being printed. They are not being stored like that of a list in the memory. For lists to work, the whole list, all the values in the list must be residing directly in the RAM. But to work with a generator, that's not the case. It will yield values in the runtime or during the runtime. Any questions, anybody?
No,
And hence, generators are very powerful concepts when you know when and how to use them. They are memory efficient. You can write a calculation of in practically infinite numbers, even on an age-old computer using a generator. All right. I'll stop sharing my screen now. I'll stop recording.